Hi, this is Gigi from Kauai Community College. In this video, we will be talking about U substitution for integration. Alright, so basic integration using the technique of having a U substitution. Alright, so suppose you have this problem here that looks pretty complicated. So what we'll do is, and just hold on to your thought for a second here. We're going to go ahead and do a U substitution here, and then I'll explain why that will work. So let U be, and when you see this, you see a composite function, the square root of 81 minus x squared. So the inside function there is the 81 minus x squared. So I'm going to go ahead and let U be 81 minus x squared. Take the derivative of that. du would be the derivative of 81 is 0, derivative of negative 2x squared is negative 2x dx. Okay, so then if we look back and do a little substitution, so change everything into the variable u instead of x, we would have square root of u, and then we would have negative du. Let's see where that comes out here. So square root of that thing is square root of u. What's left over? 2x dx. As you can see here, you have negative 2x dx being du. So positive 2x dx is going to be negative du. Change that to exponent so you can see it a little bit better. Square root is to the exponent 1/2, and we can put the negative in the front. To take the integral, we'll add 1 to the exponent, so that would be u to the 3/2, and then we have to divide out 3/2, and dividing by 3/2 means multiply by 2/3, and then you have that negative in the front, and then don't forget the plus c. Right? Now, rational exponent, the denominator is the root and the numerator is the exponent. So here you would have negative 2/3 multiplied by square root of u to the 3rd power plus c. But we didn't start out with u, we started out with x. So then the integral that we were looking at, we'll go ahead and put x back in for u. So you would have negative 2/3 square root of 81 minus x squared altogether to the 3rd power plus c. Okay, so why a u substitution? When does it work? How do we recognize that? We would have to see a u, and we would have to see the derivative of u being within this this expression. And so if you do this for a while, you will notice that x squared will yield, when we take the derivative, 2x. And the 2x is within the expression, so that's sort of your clue of having a u substitution. All right, so let's take a look at the next one here. Do we see a u and a du? In this case, we would say let u be e to the x. So du is a derivative of e to the x, and the derivative of e to the x is itself. So du is e to the x dx. So what we will see here is 5, that's the constant. This right here is u. This right here is du. Okay, so that's what I mean by recognizing a u and a du within the expression. If you have u and du within the expression, then the u substitution would be the best method. The integral of 5 cosine of u du is 5 sine of u plus c But we didn't have u to begin with. We did a little substitution to be able to take the integral. So we have to go back and say, hey, the integral that we are looking for is 5 sine e to the x plus c. And that is it. That is how u substitution works. Recognize u and du in the expression. That's your clue to go do a u sub.